Great, thank you, Jake. And you can go back on Twitter and you could actually watch the collapse at my NetWars experience as I started falling in the standings. So, but welcome everyone, welcome back from lunch. So my name is Kevin Perlow and to my right is Alan Swackhamer. We're just going to go ahead and jump right in. We have a lot of technical content that we want to cover and that we have for you to digest along with your meal. So we're going to start with just basic YARA rules here. And what we're going to do is build out a framework for how you can implement these YARA rules in a way that you can get actionable intelligence for your SOC. And so we're going to come back to this diagram a couple times. So if you're ever lost as to where we are, we'll bring it back up, and that way you can keep track of what's going on. So the first thing here is, what is a YARA rule? We're not going to spend too much time getting into the intricacies of, hey, how do you actually write one of these? It's a little bit too dry for this, but come talk to us afterwards. A YARA rule is a way that you can take strings and other artifacts left over from compiling a program, and you can write a rule on it. And so the idea behind this is if you have malware samples that are from the same family or made by the same authors, you can put in these YARA rules, and you can start to group and categorize them and do additional research here. And so some of the things you can do, we mentioned strings. There are also occasionally indicators of compromise that are in strings but left over. And you can do it based on a opcode, hex, regex, a couple different ways to write these rules. And so the one up there on the screen is extremely basic, but it's just to give you an idea of what this literally looks like. Now, we do have a couple examples up here. We're going to go through them pretty quickly, but when you review the slides later on, when they're posted online, feel free to jump in on these. So this first one here, is actually a ransomware sample that we were tracking back in, I think it was September of last year. And this had some fairly unique strings inside of it. You can see some file paths for the executables being built out if you look at it. And so after about a month and a half, this disappeared. But this was just an example of where you can track a campaign. This slide here, this shows a point of sale malware example. It's a little bit different. This is hex-based. It's really opcode-based. And so that's something else you can look at while you write these rules. This one here is, I'm going to call it a vol track dropper, but that's really kind of a misnomer. This is a rule based on a malicious Office document campaign that was dropping pony in the user's temp file, and you can see that in the strings in the box on the right. And so if you go back and look at the YARA rule to the left there, you'll see a couple of different things. We've got the Office document file header written out. We've got executable written out there. A couple different hex values, one of which is to track if the document has VBA, and so that way we're not just pulling any old Office document that's getting triggered on the rule. And we have some file paths out there and a little bit of whitelisting. So one of the things that we really do like to track are these Office documents, and the next slide will have a JavaScript thing. And these are all from malicious spam campaigns. The reason we want to track those is because you can actually go both forwards and backwards in the malware kill chain. So in going forwards, you can see what indicators it's going to be pulling off if it's downloading something. In this case, these files, these pony files, will send post requests to Russian C2 servers. Then they'll send a GET request and pull down vol track from a compromised web server. And so that's what I mean by going forwards. Now, going backwards in the kill chain, you can actually go and look at what email contain these attachments if you're talking about the VirusTotal intelligence portal. We'll get to that specific part a little bit later. But that's what we mean with that. Clicker not working. Come on. The next slide, when I get it up here, is, does anyone battery? Oh, there we are. We're good. Excellent, thank you. So this is a JavaScript dropper that we wanted to go off of. Actually, we want to start here. So when you talk about a malicious JavaScript file, it tends to be this giant block of text that you see on the left. But what you can do is run it through what's called a beautifier. And that'll actually put it in what's a more readable structure. And it gives you a visual idea of what the file looks like. And so that really helps in terms of categorizing these and in terms of writing your YARA rules here. Because what tends to happen is through a spam campaign, there will be a couple different variants of this. But the things that'll be consistent are that visual structure and then the variables. And so you can start writing a rule based on the logic around that. And we're going to be sticking with this JavaScript file as we move forward in the presentation. What this did was, this was from a Proofpoint article. They did some really good research, and they found that these JavaScript files were actually pulling down Rockloader, and Rockloader was being an intermediary file, which was then downloading Locky. And obviously, Locky's been in the news quite a bit recently. So we're going to be tracking that throughout the rest of this presentation. When we talk about writing the rule here, we want to write it, like I said, off of the structure. So we've got a couple of things going on here. On the left, we have, if you deobfuscate this, it takes time to do, but you wind up with the executable path that the file is going to be placed in and run from. And then on the right, you wind up with a GET request, and that's your network-based indicator. We also have 2 blue boxes there. Those are just other checks that the JavaScript file ran. And by putting all of these things together, you can write a YARA rule based on that. And so from there, you take your YARA rule and you put it into the VirusTotal intelligence portal. And whenever someone uploads a file to it, it's going to go and it's going to trigger off of that file if it matches the criteria here, and it's going to send a notification. And so now I'm going to turn it over to Alan, who's going to talk about what you can do with these notifications.
Okay. So how many people here have actually used Elasticsearch or Kibana to visualize data? Okay. All right. So you guys should be familiar with some of these concepts that I'm about to go through. So once we have put the YARA rule on VirusTotal and files have actually flagged, we've retrieved a notification. We can actually retrieve that notification through VirusTotal in a couple different ways. You can have VirusTotal email you the notification hit, so it'll come into your, your mailbox. You may get spam with them, if you get a lot of notifications, or you can pull it off of a REST API endpoint and get it in JSON formatted. So we're actually going to use the JSON formatting. And let me just step back a little bit here too. Everything that we have up here, as far as source code, I've released this project. There's working code on GitHub, which there'll be a link at the end, where you can actually implement everything that we talk about here in your own if you have VirusTotal Intelligence subscription. So anyway, so what we're going to do once we get the notification document from VirusTotal is we're going to index, parse that, and push it into an Elasticsearch stack. So let's take a look at what we actually get back from VirusTotal. This is the JSON document. We get back a couple different things. We get the rule name, the YARA rule name that fired, the rule set, so that's a collection of YARA rules that fired. We also get basic file metadata about that information, such as hashes, file type, and we also get antivirus scan data and match information, so the specific string matches that the YARA engine on VirusTotal's side matched on. So once we actually get this notification, we're going to want to do some stuff with it, right? So we're going to want to try to extract out some indicators. There's a couple different ways of doing that. Static extraction. Kevin Brand has a rat decoder framework where you can actually extract out obfuscated configuration files from malware. That's a good way of doing it. In this room, after this talk, there's going to be Floss, which talks about using the binary itself to deobfuscate some strings that reside in that binary. But we're going to focus on, for this talk, dynamic execution, and specifically Cuckoo Sandbox, to extract out both file system and network behaviors on mass VirusTotal notification alerts. So at this point, we've got the notification sitting in VirusTotal, and we're going to take that notification down, that JSON document, and we're going to index that into Elasticsearch for visualization and data storage, and we're also going to send that notification over to Cuckoo for Cuckoo to process it. So why even put this into Elasticsearch? Why not MySQL or SQLite or something like that? Well, because Elasticsearch allows you to aggregate on this data, give you counts of how many times certain notifications has hit, as well as do trend-based analysis of date histograms, so you can see notifications over time, how they appear, if there's spikes or any other things. You can also see if a file has been resubmitted multiple different times. And you can also export the data, right? So you can export this through the Kibana web interface, with the data table visualization, or you can export this programmatically through the Elasticsearch API. So this is a dashboard, a Kibana dashboard. You guys are probably familiar with this, but essentially what this is it's just 5 visualizations. The 2 here are area charts over time, and you can kind of see the notifications for, I'm limiting this down to just the rule set rat, so I've got a rat rule set with a multitude of YARA rules on VirusTotal. It's flagging, and over time you can see it going up and down, and in the top middle you see that split by type, so you can see overwhelmingly Windows 32 executables, but there is a little bit of unknown as well at the very top of that area chart as well. So, Cuckoo Sandbox. Why are we submitting this to Cuckoo Sandbox? Why not another sandbox? Well, Cuckoo is, it's very customizable. It's an open source project. It's written in Python. I'm using Cuckoo 2.0. I've modified the Elasticsearch reporting module just a little bit to basically visualize the data a little bit better into Elasticsearch. There's a pull request right now in Cuckoo 2.0's main branch. You guys may be familiar with like the Cuckoo modified forks. Well, Cuckoo 2.0, Cuckoo mainline has actually integrated a lot of those features in, so this is actually integrated into the mainline Cuckoo and not the forks. There's a lot of other popular sandboxes out there that we could be pushing this information into. VirusTotal does send it through their own Cuckoo Sandbox. You can retrieve that data. However, it's very limited. They do best case analysis. Malware is also VirusTotal or Cuckoo backed, and you could also send it into another proprietary sandbox such as hybrid analysis. So what really did we do with the Elasticsearch reporting module? We added this template. So this template does a couple of different things. It sets your shard count to 1, because it's logging type ingestion. We turn on compression. We added task ID. That task ID maps directly back to the task ID that Cuckoo has in its database. Report time, the time in which Cuckoo actually processed that. And we also turned strings to not analyzed. This is very important for later on when we do data aggregations because it won't split on common delimiters like white space dots or dashes. So like IPs will actually aggregate on the full IP and not break it apart. So back to the Elasticsearch stack and what we're wanting to see out of Cuckoo. We're going to want to try to get the files written to disk. Our network IOCs. Cuckoo also does some normalization of the antivirus data. They also ping in VirusTotal too. So how are we going to do this? Once we've actually got the notifications into Elasticsearch, we need to pull them somehow. So this is an example of using Elasticsearch's scan and scroll API. It's an efficient way of programmatically exporting results from indexes. We're exporting, you can see page equals es.search. That's the main function here that's doing all the stuff. The q equals at the very bottom of that, that's actually Lucene search query syntax. That's the same syntax that you guys know and love if you use Kibana. It's in the top in the text field. You can basically go into the Discover tab in Kibana, type out whatever request you want in there, search syntax, and pull that exact search string out and put it right here. And you'll retrieve all of the documents that match that. And at the end of this code being executed, hashes, it's a Python set, and it will have a unique list of all the hashes that hits for a specific query. This query is limiting it down to just the rock downloader notification. So at the end, hashes is just going to be all the rock downloader notifications. And then we're going to send that over into the Cuckoo API using Python requests. Again, I've got all this codes up on GitHub as well, and it does it automatically from ingest time, or from notification time for VirusTotal getting the notification. It sends it to Elasticsearch and also sends it into Cuckoo. So what do we really get from Cuckoo? Well, we get a ton of stuff, actually, in the summary information. We get files that are manipulated, written, touched, registries, mutexes, command line called, a lot of other different things like that. So what you actually see in the top right here is the actual Elasticsearch reporting module in Cuckoo, what it's indexing. It's by default, it's just indexing the target file metadata, the behavioral summary information, which is what you see on here, and also the VirusTotal results. So if you wanted to, you can modify this and add in additional things. And so here is a dashboard. And we're limiting this down. You see at the top it says target.file.name, star.js. So this is just the rock downloader stuff. We're limiting the Elasticsearch database to just the rock downloader notification in here. And so, and you see the data aggregations, which is every single run, 52 of these runs, 52 of these unique files in the top left, resolves host. You can see that diesel-cn.lms.hk. That means that 52 different samples beaconed out to that domain. So you can kind of come in here and do some sort of stacking analysis of this data. And I'm going to give it over to Kevin to talk about.
Cool. Thanks, Alan. So what we've done here is a lot of technical content. We built a YARA rule. We built all this infrastructure with Elasticsearch and Cuckoo. So what's the point? What you see on this screen is the result of running that YARA rule integrated into the VirusTotal intelligence portal. And you can see we actually came up with, I think it's 747 different files here. What we get out of this is we get a lot of actionable data for our SOC. A lot of times you'll see a threat intelligence report that says, Russia's pushing out ransomware. I guess that's nice. That doesn't do a whole lot for us. But when we wind up with these actual indicators, we have domains and we have IP addresses, we have host-based indicators. We can do something with that. So in this example, we have these domain-based and IP address-based indicators. With a lot of ransomware variants, it's pretty common for a key exchange to be done over the network in order to actually start performing the encryption. What we can do is we can take these indicators, and before our users even run into the spam email that they've been sent, we can already have them blocked. And so we might wind up with that case of beaconing, but nothing will happen. No files will be encrypted, no network drives will be encrypted. And so from a protection standpoint, we're in a pretty good spot. For the host-based indicators, if we aren't able to block them in time, or if we search from beforehand, we see we've already got people calling out to those locations. The host-based indicators will help us go and identify where the binary, in this case, might be located on the hard drive itself. And so here you would see it's in the temp folder. At the bottom of this, it's a little bit hard to see, but there's also VirusTotal antivirus vendor normalization. And what that is it's taking all the different antivirus detection rates across all the vendors, and it's aggregating them for you. And so again, it's not a perfect match, but it gives you an idea of what you might be looking at, especially if you were talking about a more generic YARA rule. This next slide here is there's a couple different ways to look at the data, but we want to get to this one over here. So this is another run from a different rule. This was off of Treasure Hunter point of sale malware. And so what's happening here, you wind up with the network-based indicators again, of course, but you also wind up on the host-based ones with these alternate data streams. And so what you can do with Kibana here is if you were to click on one of these, it would filter out all of the other files that don't match that weren't creating that alternate data stream, and it would just show you files that match that. So a hypothetical third case here would be if you had network-based indicators that were maybe calling out to France and Russia, you could filter out based on that geographical characteristic, and then you would hop back in and see, well, which files are communicating to those? Are those from a different threat actor? Or are those from a different spam campaign? Has this infrastructure changed over time? And you can start to build that level of intelligence. So what we want to get to last here is this case of additional API calls that you can make. In VirusTotal itself, if you have access to the intelligence portal, you can do a couple different things here. You can look at parent objects for one. A parent object is typically going to be a zip file or an email file that someone's uploaded to VirusTotal. And what it does is it takes the components of a zip file, or it takes the attachment from an email file. It includes that in what you've uploaded, but it also puts it as its own separate hash value and file with information and reporting on VirusTotal. And so the advantage there, I mentioned earlier, you take these malicious attachments, these JavaScript files, these Word documents. You can go backwards and you can see, hey, who's uploaded this attachment? And obviously, I think everyone in this room knows you shouldn't be uploading emails to VirusTotal, but people do it, so we can get the information from it since they're so kind. You wind up in a case where you can say, are people spoofing the sender address, for example? And so what you would do then is you might go and look at your iron port logs, and you would say, well, we're not seeing these network-based indicators. Is it because we're blocking the emails, or is it because we're just not being targeted by them? A good use case for the zip files is if you had an executable that was using a side-loaded DLL. Sometimes people will upload the executable and they'll upload the DLL all in a zip file. Because they became subcomponents, maybe your rule only matched on the executable, but in order to do like dynamic testing or reverse engineering, you also need the library. And so you would go back to that zip file as a parent object, and you could pull it down from that. There's also some network infrastructure pivoting that you can do from this. So on the right, you see the results of running a whole bunch of IP addresses across the VirusTotal intelligence API. And you can get executables that were either downloaded from the same URL or executables that called out to the same IP address. And so that lets you expand your network infrastructure as well, or your understanding of their network infrastructure as well. Some other things we've put up there, Central Ops. That's a really good whois resource. We have a pretty interesting case from last fall where someone was pushing out the Shifu banking Trojan. Now, I'll say right now, Central Ops, if you want to use their API, it's not free. It's, I think, $20 for 1,000 API calls. But that's still a fairly large amount, depending on what you're doing. In this case, we had someone pushing out the Shifu banking Trojan, and we went and we looked up the IP there. And the person registered to that IP address and that domain. He had 3 years prior to this, he'd been involved in a search engine optimization scheme out in the Ukraine. And so what we found in doing additional research on this person, and he'd been involved in a kidnapping scheme. It was kind of ridiculous. But it turned out he got into malware, and the Ukrainians went and put a bounty on his head, a literal, like, go kill this person bounty. And so we got that from Central Ops and from doing research off of that. So that's an example of where you want to do this sort of pivoting. The last thing we have up there is passive total. We had a really good passive DNS talk here earlier on, and so just a reminder, you can expand your understanding of network infrastructure based on that. And with passive total, you can also get some historical records as far as DNS is concerned. And so you can see if, for example, a page had been previously flagged by Kaspersky as being malicious or not. And so you can use that API as well. And so these are just ways to sort of take your research to the next step and get real threat intelligence out of it. So just to bring it all back together, what we did was we built a YARA rule for a JavaScript dropper. We identified over 700 files that were triggering this rule. And in doing that, we pulled these files down. We indexed these notifications into Elasticsearch. We ran the files in Cuckoo. And we were able to put the results of that into Elasticsearch and into Kibana as well. And from there, we did additional pivoting in the VirusTotal intelligence portal. And we wound up with something that we could deliver to our SOC that is truly actionable and something that they can handle. Again, the source code is available on Alan's GitHub page if you want to take a look at it. And so at this point, we'll go ahead and we'll take questions.
All right. On the original JavaScript that you were talking about, how long did it take you to decode that and, you know, figure out the obfuscation, et cetera? Like, how much time are you guys spending? And then maybe you're really good at it because you've been doing it for a long time. Like, what's the uptime, I mean, to get up to speed on that?
So that's a really good question. And unfortunately, the answer, I'll give you something more specific than this, but my first answer would be to say, well, of course it depends. With JavaScript in particular, if you look a month back on those Locky downloaders, you could look at the JavaScript in 2 seconds, put the pieces together and say, oh, here's where it's going to go. In that case, that one took me probably about a day. If I were to do it again, it would take maybe an hour or 2. But that particular one was kind of confusing to me. There are a couple things specific to these JavaScript droppers that you'll usually see that will help, though. One of them is they almost all make a try and a catch for the GET request. And my understanding is the purpose behind that is so if for some reason it can't call out, it doesn't hit you with an error. The user just doesn't see anything happen. So that's like one tip, I guess, to look there. Office documents. The Voltrak ones from the fall were pretty easy, but the Dradix ones and some of the Locky ones can take a while. So we did have a live incident where we were dealing with a brand new ransomware sample that hadn't been reported. We wound up never seeing it again, but that one, just in the interest of getting information really quickly, I ran it in a sandbox with the Office debugger online, put a couple breakpoints, and just took my chances like that. So that's, if you're ever in a pinch, that's something else you can do.
One thing to note, too, about the Office documents is that if they are docx and they're zipped up, VirusTotal will actually decompress those and extract out the macros, and you can write your YARA signatures based off of the macros. So you don't have to match on the actual like zip file. You can match on the child documents, which is something that's very powerful about the VirusTotal's YARA implementation.
Yeah.
Hi, in terms of use cases, how does your process work? Is this primarily something you go to after you have some kind of trigger in your environment, or is it coming out, the other way where you say, okay, there's a campaign out there, let's see if anything similar is happening in our environment? I'm just curious about sort of the human process side.
Yeah, so multitude of different ways, right? So like there's a lot of mailing lists out there where you can see like a lot of the current spam campaigns. I've been able to signature off of like techniques that are used in a spam campaign, and then later on detect that same spam campaign inside of our environment. That's very common. But if you get a targeted campaign, you can start to track those targeted threat actors to you. Such as like TA530 recently had a Word document macro spam campaign where they were making this, the file name was like the company name and then space like invoice or order or something like that, .doc. Well, we were able to signature on the PNG actually inside of that they were using, upload that to VirusTotal, and not only did we see we got hit by it, but we also saw, because the company name was inside the actual file name of the document file, we saw all these other companies get hit by it as well. And so we could actually go through and be like, yep, that guy from this company submitted this file, that guy from this company submitted this file, and stuff like that. So you can kind of see how the threat landscape as a whole is taking, right? Because your company is just one part, right, of the bigger landscape that these people are sending these spam waves out to, if you're focusing on spam waves, right? So yeah, definitely. Yeah. And you can with the TA530 stuff, we were able to identify network IOCs from other, same campaign, but from other people before it hit our network, right? So we were able to detect C2 from like a file that they sent to another person who uploaded it to VirusTotal. We pulled it down, submitted it to our sandbox, got that domain out, and we're able to put blocking detection into our own environment before we saw documents that were triggering out to that domain.
So, and one thing to add on to that too, if for some reason you don't have access to the VirusTotal intelligence portal because it's, for example, too cost prohibitive to have like VT Unlimited, other organizations do aggregate like a known good database. And so you can kind of go that route. You just start aggregating your own database for this kind of research and development. So that's another option you have.
Okay. Hey guys, thank you so much for presenting. Awesome presentation. Sir, coin. Yep. Sir.